Okay, so can you see my screen?
Yeah, I can see it.
Okay. So my task for today is on string validators. So the question here says Python has built-in string validation methods for basic data. It can check if a string is composed of alphabetical characters, alphanumeric characters, digits, etc. For instance, this function here, this method here checks if all the characters of a strings are alphanumeric, that is small letter A to Z, or the capital letters A to Z, and also 0 to 9. And so, for instance, here, print this particular string here, dot is alnum, which is alphanumeric. We've already stated that alphanumeric is this, either a small letter, a capital letter, or as numbers. So we asked to check for these methods, which is alphanumeric, alphabet, digits, to check if it's lower and if it's upper. So let me just do it on VS Code here. So for like I created a variable here. Yeah. And so we're just like what is written here. I'll just be like let me just copy the first character here. Yeah, so basically what this is doing here, if you see what I've gotten from here, is that so this particular one, print any. So this checks if a character in the string is string S is alphanumeric, like I stated earlier. So it will return true if at least one of them is either of those things, if either it's alphanumeric, yes. So for instance, let's give it let's see. If I say it comes out as true. Why? Because if this any here states, for instance, what any function does here is, so the any function in Python returns true if at least one element in an iterable, like a list, tuple, or generator, evaluates to true. So if any of the what I stated earlier, which is if it's either a capital letter, a small letter, or numbers, the any will come out as true. So for instance, here we have a number. We also have a small letter, so that's why it's true. So if we continue with the rest, for is alpha. You can see it's also true. That's because for the second one, there is a capital letter. The method here is alpha if the character here is an alphabet, if at least one is an alphabet. Yes. Yeah, we have alphabet here. So also checking the third one, which is checking if it's a digit. So far, since we have a number here, ABC 1, 2, 3, it comes out as true. So likewise with the other ones is lower and upper. Yeah, I think I made a mistake with the other one when I said, yeah. So I'll just yeah, if you notice this, the last one, which is checking if it's an uppercase, came out as false. That's because the characters here don't have an uppercase. So that's why it came out as false. If it does have an uppercase, then it's going to return true. Yeah, so basically that's what it is here. That is what the string validator is requiring. Yeah.
Okay, thank you very much. I was wondering, does it consider, because there was a mix of alphabets, I think it was A, B, C, and then numbers. When you run the method, is it digit? Does it consider first alphabet as numbers?
Which one? This one? Alpha?
Yes. No, I think the third one, and is it digit for
Yes.
character S?
What do you mean? Is it the third line 617?
Yeah, line 17, yes. It returned true, but there was the APC there. Did it consider APC as number?
No, it's because of the numbers here. It's checking, like I said, if the idea is if at least one of them is true.
Or if they okay, not all of them, okay.
Yes, if at least one of them. That's the purpose of this function any, as I stated here. So for instance, what the any function does, it returns true if at least one element, if at least if at least one of these characters here, if one of these is a digit or the other, then it comes out as true. Yes.
Well, makes sense.
So if there is no numbers, then it will not come out as maybe if I'd said ABC, something like this, you can see that it came out as false because there is no number.
Yeah.
Yeah, so that's it basically.
So thank you very much, Semi. Run it on your hacker.
Yes.
Oh, is it? Yeah, thank you very much, Semi. It was clear.
Yeah. Yeah, so this is the standard input that was given to us. And so this input here checks everything, and that's why the output is all true. Because we have a small letter, we have capital letter, we also have digits. And we also have at least one of them. Yes, so that's why. So this is checking alphanumeric, at least one of these. If it's a capital, lower or a number, so that checks true. Likewise with the rest of them. If it's an alphabet, yes. If it's a digit, yes. If it's lower, yes. If it's capital, yes. And so that's why they all come out as true. Thank you.
Well done.
Thank you.
All right.
Good explanation as well.
Okay, let me try and share mine. Can you see my screen?
Yes.
Okay. For me, I was doing the challenge time needed to buy ticket. It says there are n people in the line queuing to buy tickets where the zero person is at the front of the line. and the end -1 person is at the back of the line. You are given a zero index integer array tickets of length n, where the number of tickets that the first or ith person would like to buy is the ticket in I. Each person takes exactly 1 second to buy a ticket. A person can only buy one ticket at a time and has to go back to the end of the line, which happens instantaneously in order to buy more tickets. If a person does not have any tickets left to buy, the person will leave the line and then return the time taken for the person at the position K or zero index to finish buying tickets. We're giving an input, e.g. an example tickets. There's a list of people 1, 2, 3. 2 is index 0, 3 is index 1, and index 2. And then K is a person that is important here. So there's a person that is what you call a base case where we are measured on. So this person, which is number index 2, which is here, is the one that you must judge ourselves on. So in explanation, say in the first pass, everyone in the line buys the ticket and the line and becomes 1, 1, 1 to 1. And then the second pass, everyone in the line buys the ticket and the line person becomes 0, 1, 0. And then the person at position 2 has a successful bought 2 tickets and it took 3 plus 3, which is got 6 seconds. And then position example 2 ticket blah blah blah. So we try to explain this in the code. Okay, this code is there's another method that you can use, but this one I use Q. Remember we did Q in that book, where Q it means it's a linear data structure because you're working on a linear list. Linear data structure that has a array and the front end list where there's someone in front and there's the book at the end. Like a queue when someone is buying in a custom, where we're using the FIFO, first in, first out. So here in a step, I try to use the queue or the deck method. We initialize the queue. Each person is represented as an element in the queue, where the element stores the number of tickets they need and their index. To simulate the ticket buying process, the queue, the first person in the queue, and then we decrease their tickets count by 1. And if they still need more tickets and queue them back, the queue means we remove first person and the queue, and then we remove him from the queue, and then we decrease that 1 p to remember we must take 1, we must buy 1 second to buy 1 ticket. If he still has, and then he must go at the back of the line, and then the following one must be buy. Then take the number of turns that taken until the person at index K. Here we're given 2 in that example. It finishes buying all the tickets. So to try to explain in an example, we're given a list of 2. It was 2, and then there's 3, and then there's 2. This is the list. So in order to solve this problem, these people is the first person which is at index 0, then index 1, and there's index 2. This one is our base, which is K. This is our measurement. So this person, first person must buy 1 ticket, but make sure that these 2, 1, 2, 3, they must not finish before this one is finished. at least if they must finish in the first row, and then this one must go. This cannot just go. Let's say maybe let's say is 2. So if this one by, and then he left it 1, by 1 ticket, and then he left it 1, it goes at the back. This one it by, because it has 3, you say 2 minus 1, so you must remove, so that this one must be equal, because it come first, so you must buy 2 tickets. And then this one must buy 1 ticket. And then we check, oh, do we still have tickets? And then we say yes, this one still have 1. Then must buy 1 ticket, because it only left it 1 ticket, and then 1 ticket. So you have 1, 2, 3 second. So every time they buy, you count as 1. So this is 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6. So second that check should be 6. That should be taken to finish buying all of this, because when this one buy, they go once, buy, and then go the back, go buy, go the back. This one buy 1, go the back. So still say 1, and then they go and buy again. When the buy is finished, so it's removed. And then second one buy is finished, and then it's removed. And then this one also buy, and then at the end of it, and then we return the result, which is 6.
Okay, I'm lost. Can you re-explain the ticket type?
Yes, you may ask.
How did you get to
Yeah.
6? I'm lost. How did you get to 6? Whereas when one person buys, the number decreases. So how did you get to
Yes,
6? I'm lost.
here is 2 here. The first person is 2
Yes.
tickets, and then the second person is 3, and then the fourth, the third person is 2. Yes. The last person, this is our measurement, that this one must make sure that all of them are finished before this one is finished. The last one is finished. So in order this one to finish, when they buy, we say 1 second. So this one they buy 1, and then we left it 1 again. So when they buy, we left it 1. And then this one, because it's 3, you must buy 2 on the first opportunity, the first second. So that is going to be left with 1. You follow? So he bought 2 tickets at the first second. That each time they buy, we count. So this we buy 1, and then you count 1. This one you buy, you say 2, and this one you buy, you say 3. Each time they buy, you count the seconds. We still have 1, 1, 1, 1, all of them, right? So we go back to the line. This one you buy, because there was left with 1 ticket to buy. So you buy, and then we say 4. We add into, before there were 3 seconds. So once you buy the second time, it's 4 seconds. This one also buy 50 seconds. Now they are left with 0. On index 1, there's nothing else to buy, is removed. Index 2, index 0 is removed. Index 1 is removed because he bought second time. And then this one, the last one, also he buy, which is the 6th time he buy, and then this way we get 6. Am I making sense?
Yes, you're making sense. Thanks for explaining again. I'm following.
Okay, thanks. So okay, let me go to explanation of the code. And the code, we say Then we initialize the queue, that list. We initialize the queue where each element is a table, ticket left, and index, where it represents also the index, and then representing the number of tickets a person needs and their index in the original list. Ticket buying simulation with the queue, the first person in the queue. Then we decrement their ticket counter. We say ticket on ticket underscore left by 1. If they still have a ticket to buy, we enqueue. Enqueue means we put them back at the line, back to the queue, and then we keep the track of the total number of turns they've taken. And then we check if there is at index k, there is no ticket left, and then their turn will return to the total time taken, means the total, that's why we get 6 there. So I used code expression. I used the tag, the data structure, which is text. Imports went from the collection, import the tag, which is the tag double-ended queue, is imported from the Python collection module. It's specialized list optimized for faster appends and pops from both ends. Here we use the tag to represent the queue of people buying the tickets. And then okay, I think the method was define or rate method, which is defined from the challenges, define time needed to buy tickets. And then we give the parameters tickets, and then the K, where our base, how many, who's our judge. So where we assign Q, and then we give the method tag tickets in I, and then I for in any range. We check the length of the ticket, and then we initialize the time to 0. Define the function, it's time to buy take to argument. Tickets elite, where each element represents the number of tickets each person need to buy, and then K, the index of a person whose total ticket time we want to calculate, and then initializing the Q, the Q is initialized where each element is a table ticket in I, and then I, this table holds the number of tickets a person needs and their index in the original list. So for example, if the ticket is 2, 3, 1, the one that we give in the challenge, and then the Q will be deck. This is the person 2 in index 0, and then person 3 in index 1, and then person 2 in index 2 And then time a counter to track the total time or 10 seconds so far. We initialize it in 0. And then we use the loop while we're looping on the queue. The tickets on the underscore left index assigned to queue. The dot we use the method pop left, and then time at one time each time a person take a 10. On the question they said 1 second, but here you can just say 1 time. The loop continues as long as there are people in the queue, and then the queue operation queue dot pop left. Remember when we're reading that book, the pop, my mouse, the pop left remove and return the first person in the queue. This method pop left. And then we say tickets on the left, that variable, the number of tickets the queue person has left. And then the index, the position of this person in the original tickets list. And then we increase or increment the time. Each time a person by time is incremented by 1. And then we check the list, the ticket left. We say if the ticket left minus 1 is greater than 1, and then the queue append we add ticket left in the index. So after buying 1 ticket, we check if the person still has a ticket left. Check index underscore left minus 1 is greater than 0. If yes, this person is appended back to the queue. So we put him back at the queue with 1 less tickets taken. This simulates the person going back of the line after they are 10. Check for completion for each person in K. If the current person is the one we are interested in index, for example, the one I said which index 2 is equal to K, and then they are just put their last tickets, and then we minus if there is 0, the function return the total number taken, which was 6 in our calculation, and then this answer to the problem, the total it take for a person to finish buying all their tickets. I think it's same like just I'm running the code. So let me try and then do it. Okay, yeah. We don't have collection imported here. Collection imports deck. Is it deck or queue? And then we have the time required already. Time required to buy ticket. Then queue. We assign to deck. The ticket with the index I. And then index it at 0. Then we run a for loop in range. Check the length of the people or the tickets. Initial sum to 0. Run a for loop of the queue. Ticket left. Index. Assign to queue. Use the pop left. If ticket. There queue. At I'll take them at the back of the line. And let's check if case done and there's no ticket left. Then we return the time taken to output. Okay, there's no errors. I'm putting S. Okay, what wrong did what did I put here? if in this code you can take it left and let's go to 0 return time, and then the queue append. Then take it -1. Oh, I never add time here, I think. So, yeah, I think you get it. Yes, I think it accepted. I think that was it. If there's any question, and then we may ask. Or if it was
Well
clear.
done on as well as your well done on the presentation as well as your explanation of the code on how you did it. My question is, how do we submit our work to GitHub from the HackerRank platform or Leetcode platform? Can we do it straight from there?
I'm not sure if we can do it. So usually for me, I code it on the VS Code and then push it out from VS Code. Yeah.
From HackerRank or any of the two platforms, I can't. Also, have you tried that?
I haven't tried that one, but I think because I do not know, I'm not sure if somebody knows. I've not used that to push it straight from the platform to it.
Okay.
Samir, have you tried?
No, I've not tried it, but maybe there is a way it can work. I have not tried it. There's a possibility, but I have not tried.